Okay, so let's start the first question. First question is the string is fixed at both ends. Length is 60 centimeter. Tension in the string is 65. Linear mass density 5 into 10 to the power minus 3 kg per meter. And the question is asking us, if string is vibrating in its second overtone and amplitude at its NT node is 0.25 centimeter, what is the maximum transfer speed and acceleration of string at NT node? Okay, so the information here is it's in second overtone. Now, second overtone when the string is fixed at both ends. Okay, so if you look at string fixed at both ends, means what are its frequencies? I am just writing V by 2L fundamental tone, 2V by 2L second harmonic first overtone, 3V by 2L third harmonic second overtone. So he is talking about this. Okay, so 3V by 2L. 3V by 2L means 3 loops. This means 3 loops. Now 3 loops means 1, 2, 3. Okay. Second important thing is he is saying that amplitude at NT node is 0.25 centimeter. Okay. So amplitude is 0.25 centimeter. Okay. Like this. What is he asking us? Velocity. Velocity at NT node. That means if I look at the velocity of the particle which is at NT node, it is actually A omega. So for omega, the first thing that I require is frequency. Okay. I can get frequency from here, but first I require velocity. So how to get velocity? Velocity is root over T by mu. T given to us 65. Mu given to us. Okay, this is 13. So V is 13 into 10 to the power 3 or 1.3 into 10 to the power 4 meter per second. We got this. Okay, so obviously we can get frequency also, there is nothing else. Frequency is 3V by 2L. Okay, so 3 by 2L, 2L 0.6 into V, which is this, which you can write as 10 to the power 2 root over 1.3. Okay, this is our frequency. Now the question is, what is the maximum particle speed at NT node? And the question is, at NT node, what is the amplitude? It's given 0.25. Okay, so velocity of particle is actually A omega. A is what? Amplitude. It's given 0.25 into 2 pi into frequency. So 0.25 is here, 2 pi, and frequency we already got. This is here. So 3 by 1.2 into 1.3 square root into 10 to the power 2. Okay, this will be our answer. So 0.4. Roughly, if I do this, this is 6, 12 pi, 1200 pi into root 1.3. Okay, but this 0.25 was in centimeter, I guess. 0.25 was given in centimeter. So first thing is we need to convert this into meters. So by 100 is here. So by 100 is here also. This gets cancelled. So it becomes 12 pi root over 1.3. That should be the answer for the maximum particle speed. Okay. Then second thing is, what is its acceleration? Acceleration formula also we know. They are asking at amplitude NT node value. So no problem here. So acceleration also we know, because the particle is doing simple harmonic motion. So acceleration will be omega square A. Omega means 2 pi f square. A value we know 0.25 centimeter. So that's it. So put the value, you will be getting the answer for acceleration. In the same question, its next part is, what are particle speed and acceleration? What are particle speed and acceleration at a distance 5 centimeter from node? At a distance 5 centimeter from node. Okay. Now how to find it? Now first of all, whatever the particle be in this standing wave, all are doing simple harmonic motion, there is no doubt about that. But what we know is every particle in this standing wave has different amplitude. So for this particle which is at 5 centimeter from the node, we have to find what is its amplitude. Okay, that's only the main thing. Now, this is NT node. Okay, we can find out what are its positions also, because this is 60 centimeter given. We know that this is lambda by 2, this is lambda by 2, this is lambda by 2. Okay, so each lambda by 2 basically is of 20 centimeter. Okay, so this NT node from here has to be at 10 centimeter. So the question is asking you somewhere in the middle here. Okay, let's see. I know that whenever we are writing the equation of a standing wave, we write it like this: y equal to 2a sine of kx cos omega t. Right? And this basically is the amplitude of standing wave. Okay. This is the amplitude at NT node. Right? What are we finding? We are finding amplitude of a particle which is at 5 centimeter from the node. That means x value is 5 centimeter. Okay, let's put it. This is amplitude of that particle. This is equal to 2a sine 2 pi by lambda into 5 centimeter. This will give us the amplitude of that particle which is at 5 centimeter. Okay. Now, what is k? Now, k means 2 pi by lambda. And what is lambda? So, we know that in this particular case, lambda by 2 is 20 centimeter, or 3 lambda by 2 is equal to 60 centimeter. 3 lambda by 2 is 60. You can see that lambda by 2, lambda by 2, lambda by 2. Okay? 3 lambda by 2, 60. This is 20. So, lambda is 40 centimeter. We'll place it here. So, what we are getting? Let's see. This is 0.25 centimeter. Sine 2 pi by 40 into 5. So 5 8 ja. This is 4. This is sine pi by 4. Sine pi by 4 means 1 by root 2. So 0.25 by root 2 centimeter is the amplitude of the particle which is at 5 centimeter from the node. After knowing this, what we have to do? We have to find speed of this particle, maximum speed of this particle. Now, if this particle is doing SHM, we know that its maximum speed is going to be a omega. What is it saying? This is it saying. So, 0.25 by root 2 centimeter, convert it in meters. It became meters into omega. That's 2 pi into frequency. Frequency we already calculated for previous question. Okay, same way acceleration of this particle. Again omega square a, maximum acceleration. Okay, it's omega square a. We are going to put the value. But remember one thing, velocity is maximum at mean position, acceleration is maximum at extreme position. But since he is asking maximum, I am writing it over here. But if he would have asked me acceleration at mean position, I would have written 0. Okay, this was question number 1. Let's see question number 2 now. So question number 2 is, there is a wire of length 2 meter fixed at both ends and it's vibrating in its fundamental mode. Vibrating in its fundamental mode. Okay. Tension in the wire is 40 Newton. and the mass of the wire is 0.1 kg. Okay. At the midpoint of wire, because it's a fundamental bone, that means it's like this. Okay. At the middle of the wire, there is empty node, and the amplitude is 2 centimeter. Amplitude is 2 centimeter. Okay. All right. Amplitude is 2 centimeter. Then find the maximum kinetic energy of the wire. Now, very similar question we did in the previous class, in which we found out that what is the energy confined within a loop. And this is also one loop only. Okay. So same question is there. Okay, we have to find it. Maximum kinetic energy or maximum potential energy or total energy. All are same questions. Why? Because when it is at extreme, it is having all potential energy. When it is at mean position, it's having all kinetic energy. And in between, it is kinetic energy as well as potential energy. So, but total energy is constant. You can find anything with that formula. Okay. So, if we look at kinetic energy, if we are saying what kinetic energy we will be getting, let's say a particle is there, which is, we can write it as its mass is mu dx, that is dm, and its velocity, you can say its maximum velocity is a omega whole square. Okay, 1 by 2 mu dx omega whole square. We can do with that formula also. If you remember that formula, from there also we can do this question. So half mu dx omega a whole square. Now, many things we have to find. Amplitude is given to us, no doubt about that. We have that amplitude. Omega we have to find. Okay, mu dx also is there. Mass by mass is there, length is there, and dx. Okay, so 1 by 2, mu means mass by length, that is 0.1 by 2 dx. Okay, for this amplitude, because here x is there, so for that I am going to write amplitude in such a way so that I can integrate that. Okay, so I am writing this as 2a sin kx. Okay, square and omega square. Omega square obviously is constant. How can we find omega? Very simple, it's a fundamental tone. Okay, so fundamental tone means this, and this distance is lambda by 2. It's a lambda by 2 equal to 2. So lambda equal to 4 meters. Okay, then we have to find frequency. How to find frequency? You know that frequency is actually V by 2L. V by 2L. So 1 by 2L into speed root over T by mu. So frequency will be getting 1 by 2 into 2. Tension given to us is 40. Mass of the string is 0.1 and length is 2 meters. Something like this. Okay, so what we are getting? It's 1 by 4. This 0 is gone here. So 40 into 20, that is 800. So we can write this as 400 into 2. That means 20 root 2. So this is 5. So it comes out to be 5 root 2 hertz. That's frequency. So frequency is not an issue. We got the frequency over here. Okay. So that means we have omega also. But kinetic energy, how to find? So here we have to integrate it from where to where, and what we have to integrate? This function on. So remaining thing you can take out outside. 1 by 2 into 0.1 by 2 into 2a omega square. Here is sine square kx dx. Now from where to where we have to integrate? From this point to this point. 0 to lambda by 2. Sine square kx integration will be what? And first of all, this we have to convert into cos 2 theta function. Okay. What is cos 2 theta function now? Cos 2 theta function is 1 minus 2 sine square theta. Okay. Cos 2 theta is 1 minus 2 sine square theta. So Then what we can write this as? Sine square theta we can write as 1 minus cos 2 theta by 2. Okay, so here this I can write as 1 minus cos 2 theta, that means 2kx by 2. Okay, 1 minus cos 2kx, because it's cos 2 theta. In place of sine square theta, 1 minus cos 2 theta by 2. So 1 minus cos 2kx by 2. Okay. Then what? Now we are going to integrate this function only. Let's write half separately. That's half, and here is dx. So half is outside dx, 0 to lambda by 2 minus, again half outside over here, cos 2kx dx, 0 to lambda by 2. Okay, this function we will remember because in this one only values we have to put and solve. 1 by 2 dx integration x, then place of x first lambda by 2 minus 0. The answer will come lambda by 2 minus 1 by 2. Its integration is sine 2x by 2k, sine 2kx by 2k. Okay, then limit 0 to lambda by 2. Okay, now this part I'm rubbing here. Okay, and this part we are going to put this value here. So this is lambda by 4 minus 1 by 2 or 1 by 4k. Now this value we have to keep in place of x. Okay, so sine of, and sine 0 will be 0 only. So that part I am not writing, only lambda by 2 part I am writing. So sine 2 into 2 pi by lambda k value into lambda by 2 minus sine 0. I am not writing that. Okay, so lambda gets cancelled, 2 and 2 gets cancelled. Sine 2 pi, sine 2 pi is also 0. So that means this entire factor is gone. So what we are getting? Lambda by 4. Okay, only thing that we are getting from here is lambda by 4. So this lambda by 4 we are going to put it over here. So what's coming here? Let's see. 0.1 by 4 into 2a omega square lambda by 4. 2a value we already have. Given to us as 2 centimeter. We'll put it over here. Omega 2 pi a whole square. Lambda value also we have. So that means we know that what is the kinetic energy maximum between the two ends of this loop. Okay. Then what is the next question? Next question in the same one is asking us, at the instant the transverse displacement is given by 0.02 sine of pi x by 2. What is kinetic energy of the wire? Okay, if the equation is changed, let's see what equation is changed. We'll try and see. Equation of the wave here, the standing wave is given to you as y equal to 0.02, that means 2 centimeter sine of pi x by 2. That's amplitude is given to us. What is kinetic energy of the wire? In this one, k value is given pi by 2. That means lambda value, pi gets cancelled. Okay, lambda value is given 4. Here also lambda is 4. So whatever we did it correctly for this particular thing only. Okay. So what is kinetic energy of the wire? Same kinetic energy of the wire we got. Okay, we already have calculated. Same thing. At what position on the wire does kinetic energy is maximum? Kinetic energy is maximum near node. When all the particles are in node, or that means all the particles are in mean position, our string will have maximum kinetic energy. Okay. When potential energy is maximum? Potential energy is maximum when it is at antinode. Okay. So when the particle or the string is in antinode position, potential energy is maximum, and when it is in mean position, kinetic energy is maximum. Okay. Let us see third question then. What is third question? The third question is when there is a spring is a combination. So this is steel and this is aluminum. Okay. Steel wire's length is 80 centimeter, whereas aluminum's length is 60 centimeter. Okay. Tension is given 40 Newton. Area of steel is given 1 mm square. Area of aluminum is given 3 mm square. Okay. Density of aluminum is given 2.6 gram per cc and density of steel is given 7.8 gram per cc. Okay. What is the question then? What is minimum frequency? What is minimum frequency of a tuning fork, of a source, you can say, of a source which can produce standing waves in the system. Okay. Now minimum frequency, always remember, is a fundamental frequency, a fundamental tone. So if you are looking for minimum frequency, then I would assume that here there is a fundamental thing. Here has to be a fundamental thing. I don't know about this side. I can't say anything about that side. But here definitely it has to be fundamental. Okay, here can be more also, but here we will be looking at fundamental. Okay, let's see. So we are looking for fundamental tone in steel. So what is the length is given to you. Okay. Alright. And one more thing you remember, because these are connected in series, then frequency here and frequency here will be same. Tension will be same. Tension also is same and frequency also will be same on it. There will be no change in it. Okay. So we are looking for fundamental tone in that, but we don't know exactly it will be fundamental or not. We can't say that. Okay. But one more thing is there in it. What they want is this point has to be a node. Okay. This point you have to make a node. That's a compulsory. It's in question only. This point need to be a node. So we know that here also node is there, here also node is there, here also node is there. Okay. Now, if these two ends are fixed, so I am assuming that in this particular case, n, velocity of the string in steel by 2 into 80 centimeter. Okay. Now I consider this as n loops because we cannot say we want it to be in fundamental, but whether it's in fundamental or not, we don't know. We have to prove it. So I consider maybe there are n loops. Okay, or n1 loops. And here I am considering there are n2 loops. So n VST by 2L equal to n2 V in aluminium by 2 into length of that. This gets cancelled. Okay, so now what we are getting? N1 velocity in steel by N2 velocity in aluminium equal to 0.8 by 0.6, that means 4 by 3. Okay, this is first thing. Now this velocity in steel and velocity in aluminium I am going to find because I have T also and I have mu also. First of all, we will find mu. What is mu of aluminium? Rho is given to me and area also is given to me. Okay, so rho means mass by volume. Mass by volume into area will give us mu value. Okay, so rho aluminium into area of aluminium. Where is it? Yeah, into 3 mm square. We'll get mu value. So rho is 2.6 gram per cc. It's in centimeter, but this is in meters, millimeters. So we have to convert this in centimeters first. What you can do, or let it be like that only, no problem. Let it be, because anyhow we are going for the ratio here. and both it is given in mm, so it will get cancelled, don't worry. Mu of steel, again density of steel into area of steel, density is 7.8 and area is 1. Okay, so what are we trying to find? Velocity in steel by velocity in aluminium, that is T by mu s by T by mu aluminium root. Now T and T gets cancelled. Why? Because the same tension. Then Vs by Va is equal to what? Mu Al by mu S. What is mu Al? 2.6 into 3 is 7.8. What is mu St? 7.8. 7.8, 7.8 gets cancelled. That means velocity is same. 2.6 into 3 is 7.8. So you are putting 7.8. What is mu St? 7.8. Cancel. That means velocity is same. That means it is cancelled. Okay. So number of loops in steel to number of loops in aluminium, 4 by 3. Okay. That means 4 loops are there in steel and 3 loops are there in aluminium. N1 by N2 is 4 by 3. That means what? In steel there are 4 loops and in aluminium there are 3 loops. Okay. Now what the question is asking us, minimum frequency of the source. Very easy that is now, because we know that how many loops are there. So let's go for the steel. We are saying in steel there are 4 loops. So frequency is 4 into V in steel by 2 into length in steel. Okay. So this is 2 by 0.8. Now velocity in steel is what? Root over T by mu. What is T? 40. Now what is mu? Now if you remember, mu we calculated 7.8, but 7.8 what? We multiplied rho with area. What was rho? Rho was 7.8 gram per cc, and what was area? 1 mm square. So let's find it first. Okay, mu 7.8 gram per cc. Now 7.8 kg per cc. We have to convert centimeter cubic into meter cubic. Okay, into 1 mm square. We have to convert that into meters. 1 into 10 to the power minus 6 meters square. This and this gets cancelled. What we got? This. Let's put it over here then. Here. This is F is equal to N V by 2L. So V value we are writing root over T by mu. Mu is this. 7.8 into 10 to the power minus 3. Okay, what's going to come? So F equal to 2 by 0.8 into 40. We can take this up into 10 to the power 3 by 7.8. So this is 4 into 10 to the power 4. What will come out? 2 into 10 to the power 2 is outside by 7.8 is here. So this is the frequency of tuning fork, which is going to produce the minimum frequency in this string. Okay, so that's all for now. We'll close the class over here.